Good morning, ladies and gentlemen. Welcome to this video on graphing quadratics. I hope you have your notebooks out. This video, I won't lie, will involve taking a lot of notes, so you're probably going to have to pause and copy down what I already have pasted on the screen in some parts. By the end of the day, I would like you to be able to see a quadratic in that equation, a quadratic in that form, and do some math stuff to it and be able to produce the graph accurately without using a calculator. Clearly, a calculator is good for double checking, but you're expected to be able to graph without using a calculator, finding all features. So you don't need to copy this, but it's just a reminder of what a parabola looks like. It's formed from cutting a cone at an angle, which is kind of neat. What we have here, and please copy this, are all the features of a quadratic. Quadratic equation forms a parabola. It will have possibly two x-intercepts, possibly one, possibly none. There will be a y-intercept. There will be either a minimum or a maximum, and we'll call the minimum and the maximum the vertex. And the vertex runs along the lines of the axis of symmetry. Essentially, given an equation, you should be able to find all of these features. All right, so let's look at how we actually do that. Sometimes quadratic is given to us in useful forms, and sometimes not. The least useful is this one. This one's called the general form. You can tell some things by looking at the general form. Firstly, if a is greater than 0, it'll be concave up, smiley face. So if it's positive, if a, the leading coefficient, is positive, it's up, negative is down. It also affects the steepness. So if the number of a is between -1 and 1, you'll have quite a wide graph. Or if it's a higher number, we'll have quite a steep graph. All right, the more useful forms. This is called axis-intercept form. If you have an equation or a quadratic equation that has already been factorized into x take p, x take q, you're doing pretty well because then p and q are the two x-intercepts. And if you add p and q together and divide by 2, you get the axis of symmetry. Then what you do if you get that x value and you want the turning point, like the y value, you sub it into where the x values are and you'll get a number out. We'll do that in a minute. This doesn't really exist. It's in the table for completeness' sake. This last one, though, is called turning point form. Turning point form is very useful. It lets you know the turning point. If you can get a quadratic into this form, and you can do that by completing the square, then you can find its turning point. So the three forms that we're looking at are axis-intercept form, vertex form, and general form. They are all different ways of writing the same thing. In theory, you can grab any equation and manipulate it to make it look like one of those forms. All right, so let's say we're given something in axis-intercept form, and this is definitely the nicest one to deal with. All right, so let's sketch it, showing all features. 2, x take 1, x plus 3. Okay, so to find the y-intercept, you let x equal 0. So letting x equal 0 falls out quite nicely. What that means is that we have 2 y equals 2 bracket neg1 bracket bracket 3 equals, what's that, -6. The y-intercept is -6. And that's the easiest to find almost every time you let x be 0. What that means is somewhere on the graph, you can let this be -6, and it will pass through there. All right, cool, good start. All right, x-intercept. For the x-intercept, you let y be 0. All right, so if we let y be 0, we have 0 equals 2 x take 1, x take plus 3. Now, for this to work, you are looking at null factor law. So it's already factorized for us, which is fantastic. You're looking for values of x for which this will equal 0. And the values of x from here are x equals 1. From here are x equals -3. The 2 actually doesn't affect what the x-intercepts are. All right, so x equals 1, x equals -3. 1, minus 3. Clearly on grid paper, you'll be able to do the scale a little better, but they are x-intercepts. Axis of symmetry. Axis of symmetry falls halfway between 1 and minus 3. And if you've got it on grid paper, you can probably count it into the middle, but the other way of counting to the middle is just adding them together. So 1 plus minus 3 over 2, and dividing them by 2. That finds you the average or the midpoint. Minus 2 on 2 is minus 1. So here is the axis of symmetry at x equals minus 1. And note, if you're asked for the equation of the axis of symmetry, x equals minus 1 is the equation of the vertical line that goes down. So we will turn around that point, and you'd be expected to give it as an equation if you're asked for it as an equation. All right, vertex. To find the vertex, we sub in x equals minus 1 into the equation. So if we sub that in, we get y equals 2, minus 1 minus 1, bracket, bracket, minus 1 plus 3. And what that's going to give us is 2 lots of minus 2 multiplied by 2 is neg 8. So down here, on the axis of symmetry, at minus 8, we're going to turn. All right, then this is going to go disastrously on a computer. But on paper, you'd be able to sketch it relatively smoothly. So intercept, turning, y-intercept, going through the 1. And draw arrows in the end to indicate they're going forever. Arrows on here, you're going to label x and y and all that stuff. But that nice smooth parabolic curve looks nothing like what I've drawn. But the important thing really is that you cut through those key points that you've identified, and that you can identify them from the formula. All right, so let's say we're given one that's not as nice as that. That's already factorized. In fact, we know how to factorize formulas, so often we can take a quadratic, factorize it, and then do this, which is great, but not always. Let's say we get one like this. One like this is actually pretty neat, because we can find two things straight away that let us have a pretty good shot at curving it. One is the y-intercept with that x be 0. So y equals 2 minus 1 squared plus 3 is 5. The y-intercept is 5. We are going to cut here at 5. The vertex, you read straight off, is 1, 3. Once again, from the transformations topic, that's a trap. The vertex is the opposite sign of it. So this graph turns at 1, 3. 1 across, 3 up. And you know that if it turns there, that will be the axis of symmetry. Axis of symmetry is x equals 1. And we can have a decent shot at forming a quadratic around there. Now note, this works really well because there are no x-axis intercepts. If we did try and factorize this, we would fail. If something doesn't have x-axis intercepts, it doesn't factorize. So this is the most information we can get in terms of drawing it. If we did want to, we could choose a point out here, say the point 4, and sub in x equals 4 into the equation, and that would give us another point here that would just make our curve a little smoother because it aims up through a point. All right, onwards. Let's say we're given this. Y equals 2x squared plus 4x plus 5. Let's say we try and factorize it. And let's say that fails. If we failed at factorizing it, maybe it can't be done, which is fine. Next step is either quadratic formula or completing the square. Both work all the time. It's usually preference which way you go. Here we're going to go completing the square. All right, so to complete the square, our eventual goal is to make it look like this. That is something we can tell a lot about because we can just read the vertex off. All right, so we go through the process of completing the square. Ditch the 2 first. Y equals 2 bracket x squared plus 2x plus 5 on 2. It's all right if you've got a fraction out the back, it's just not going to be particularly pretty. All right, now completing the square like this, we haven't done before, but it's fairly similar. y equals 2 bracket x squared plus 2x. Now we're going to take that 2 off to the side out here, divide it by 2, square it, and what we get is 1. We add 1 on, plus 5 on 2. We take 1 off. So what we've done is added 1 on, taken 1 off. We haven't changed anything. And importantly, we've done it all inside this bracket with the 2 out the front. If you don't do that, eventually this 2 is going to hit there, which is fine, and we want it to, but if you write the -1 outside the bracket, then that doesn't happen and you effectively get this wrong. Alright, so the way we've set this up, this is a perfect square. It's probably the first perfect square you guys saw in year 9. 2 bracket x plus 1 squared. Then let's simplify this. 5 on 2, take 1, is 3 on 2. You might need to convince yourself of that later. Alright. Note how I've introduced a second set of brackets. That's quite important because this 2 is going to come in and go in front of that bracket and hit that fraction. So y equals 2 bracket x plus 1 squared. 3 on 2 times 2 is just 3. Alright. And then we've got it in our correct form. We know that now it turns at -1, 3. And if we let x equal 0, so if we let x equal 0, we'll get the y-intercept. X equals 0 here is 5, another 5. So we're turning there, crossing here, and we have a quadratic that looks like, ho, that's my worst yet today. Looks nothing like that. Alright, I recognize we're short on time, and you guys are probably taking notes like crazy. Well done. Alright, let's say if you can't factorize and you need the roots, so you need where it crosses the x-axis, then completing the square doesn't help you a huge amount. Actually, if we wanted to find the zeros here, we would let y be 0, and we would have 0 equals 2 bracket x plus 1 squared plus 3. Our first thing would be to take the 3 over and then square root. But you can't square root a negative. You get imaginary numbers, which is why there's no roots here. But if you can't factorize and you need the roots, more normally we go quadratic formula. Completing the square also works, but quadratic formula. So, given this in general form, factorizing is failed, we don't feel like completing the square. The roots are 2 from the quadratic formula, and the turning point is minus b on 2a, which you can either think of coming from the average of these guys, average of the highlighted ones. So if you add that to that, the only difference between them is this discriminant bit. And so when you add them, the discriminant effectively cancels out. And then if you add them together and divide by 2, you get to here. Or the other way to get to there is using calculus, or having on your cheat sheet, which is why you're taking notes right now. So please do have this down on your cheat sheet because they will give you the 3 key points. The steps are, you can find the axis of symmetry just by doing minus b on 2a. Once you've got that x value, you can put it in to where all the x's are, and that gives you the y coordinate of the vertex, so then you've got this point. The y-intercept is c, it's one on its own, so we should probably point out that in our graph is c every time. Find the x-intercepts by solving that, either using factorization or the quadratic formula. There, and there. Alright, I'm sorry I've set a new record for length of video, but there are a lot of notes to get through in this topic. Thank you very much. I will see you guys tomorrow.